In this training module, I will be discussing ventilating of confined spaces and non-hazardous locations. If you need information on hazardous location equipment that we offer, open the Hazardous Location Training module. To understand confined space ventilation, we first need to understand by definition what a confined space is. The federal government regulation, OSHA 1910-146, defines a confined space. In that document, it states, a confined space has limited or restricted means for entry or exit and is not designed for continuous human occupancy. Confined spaces include, but are not limited to, vaults, tanks, storage bins, manholes, pits, silos, process vessels, and pipelines. It is important to be able to identify confined spaces because they need to be ventilated properly to ensure worker safety within that space. For additional information, consult the Occupational Safety and Health Administration's 1910-146 document. Now that we have identified by definition a confined space, you must evaluate it in order to ensure you select the proper equipment for that job. Where is the confined space located? This is fundamental to equipment selection. For example, more or less ducting may be needed to reach the confined space. Is electricity or compressed air available to power the ventilation equipment? What is the volume of the confined space? This is important to properly size the ventilation equipment to achieve and maintain the stabilization of the confined space atmosphere, thus ensuring maximum worker safety. Hazards posed by the entry. Is there the potential or known lack of gases present? Can the environment become explosive or immediately dangerous to life and health? These conditions dictate the use of equipment designed for hazardous locations. Work process. What is being done? This is essential because while an inspector and a welder could be working in the confined space, the welder may need more ventilation. It is best to select equipment based on the most extreme ventilation circumstances for a given confined space. More is better. Ventilation stabilizes the atmosphere and allows workers to safely enter and exit the confined space. Ventilation initially makes the atmosphere in a confined space stable. As work is being done, although it's stabilized, it can become unstable again. Ventilation during work processes can slow the change down, keeping it safer longer, allowing the worker's safe exit should it become critical. Respiratory protection protects the workers from respiratory distress, from work being done, or in the event of ventilation failure. Ventilation does not always guarantee breathable air for the worker. Fall protection and personnel retrieval protects the worker from falls and or helps the worker exit the confined space. It may or may not be required depending upon the confined space. Personal protective equipment, PPE. This equipment is normally specific to the job being done. Some examples: hard hats, safety glasses, welding helmets, and electrician gloves, just to name a few. To recap, we've determined what a confined space is, learned how to evaluate it, and how to use the evaluation to select the proper equipment. Now let's put it all together and look at some of the accepted procedures to include in your development of a confined space program, specific to your needs as referenced in OSHA 1910-146. First, calculate the volume of space using the dimensions from the confined space evaluation. Use instrumentation to obtain initial gas levels prior to entry. Set up and use the ventilation equipment. After purging the space, perform the gas instrument test again for entry levels. Ventilation must remain continuous to maintain a stable environment. Enter the space with the other equipment in place, such as gas detection, fall protection, respirators, and PPE. The most common technique to ventilate is positive pressure ventilation. Positive pressure ventilation forces fresh air into the confined space. The fresh air dilutes the atmosphere within the confined space and forces the diluted atmosphere out of the work area. One complete exchange of the confined space atmosphere is referred to as a purge. Consult the American Industrial Hygiene Association for recommendations regarding the number of purges needed for your application. If dual openings are available, both will be used to achieve the desired result, which is a stabilized atmosphere within the confined space. Now that we understand the basics of confined space ventilation, let's discuss the most commonly asked question. What type of blower should you use? The answer will depend upon the confined space. Let me explain why. There are so many confined space situations, locations, sizes, and other variables that there's no one-size-fits-all solution. The first thing to consider is the blower certified for its intended use. For example, if it's going to be used outdoors, is it approved for outdoor use? Surprisingly, not all blowers are. The next thing to understand is how to evaluate a blower. Pay attention to the CFM, cubic feet per minute specifications after ducting is attached to the blower, not free air delivery. What's CFM, you ask? CFM is the measurement of the volume of airflow over time. This is important because if you need a large volume of air in a long ducting run, then a centrifugal blower is a better option, based on the CFM at distance the blades can produce. Why can the centrifugal blower do this? Because the squirrel cage design has more blades and produce higher pressures than the fan blades found in an axial blower. What is important is how much air through ducting can be delivered at distance into the confined space, not how much free air the blower can produce without ducting. More air into the confined space is more purge cycles. More purge cycles equals more stability. More stability equals safer work environment for the workers. We understand that this is a lot of information that may be new to you. If you need additional information, we have a blower selection video on YouTube. Additional considerations when selecting a blower is to determine if there are any workplace lifting restrictions. An ergonomic roll cage not only provides multiple lifting points for two-person lifting, it also protects the blower components from damage during transport. If versatility is important in your blower decision, a dual-speed electric blower may be the answer. These work well in small and large confined spaces. And finally, you may not have electricity. If that is the case, a gasoline or air-powered blower would be excellent options. Now that you know the difference between centrifugal blowers and axial fans, let's explore some options to consider when selecting an axial fan. Axial fans come in different sizes. The sizes refer to the diameter of the ducting that attaches to the blower. The larger the fan diameter, the more airflow produced for ventilation. Not sure what size to use? Think about time and space. If you're working in a smaller space, the 8-inch should be sufficient. It's the most commonly used. If you're working in larger spaces or need additional purge cycles, the 12-inch axial fan would be a better option. Be sure your confined space openings can accommodate the 12-inch ducting. Your bottom line can be affected by which axial fan you select. The canister fan is a two-part system which includes a duct canister and axial fan. The ducting canister quickly and easily attaches and detaches from the axial fan, making for faster setup and teardown, increasing worker productivity. It also extends the product life of the ducting during transport and storage. Once again, versatility is an important point in ventilation selection. The inline axial fan can be used alone as a standard axial fan or can be used inline to extend ducting length for longer ducting runs. Blowers, fans, and ducting are not the only things you should research when selecting your confined space ventilation equipment. Choosing the appropriate confined space ventilation accessories can save time and money while adding to worker safety. The best example of this is the saddle vent. The saddle vent is amazing in its simplicity. Use the saddle vent with any blower or fan to increase worker productivity. The saddle vent allows for continuous ventilation without ducting removal, maintaining continuous ventilation in the confined space area until the job is complete. Without the saddle vent, the ducting will have to be removed so the worker can enter and exit the confined space. This slows down the work process, in turn costing more money and could make the environment dangerous due to lack of ventilation. I know we have covered a lot of information and some of it's new to you. To summarize, these questions will help guide you in getting started making a confined space entry checklist. What type of confined space will be entered? Is it a sewer, a tank, a silo? What are the dimensions of that confined space area? Do you have calibrated gas meters for the confined space workers? What is the quality of the ambient air going to be forced into the confined space? Is there potential for an explosive atmosphere? How many access openings are in the confined space? Do you have a blower designed for the job? Will you have access to electrical service or compressed air? Do you have the right ducting and accessories for the job? Key things to remember from this training module are: what is a confined space? How do we evaluate a confined space? Positive pressure ventilation is the most common way to ventilate a confined space. Types of ventilation equipment are centrifugal blowers, which have a squirrel cage, and axial fans, which have traditional fan blades. And the saddle vent increases productivity and worker safety. We'd like to thank you for taking time for this training module. Should you have further questions or need assistance, contact Air Systems International, the leaders in innovative safety products for over 30 years.